Go. Okay. Right. Okay. I know some of them, they get hard really fast in higher level, as in the examples weren't that hard, but now I'm supposed to be able to do these. But yeah, you are. Right. Okay. So which ones am I doing? So I gave you 1, 2, 1, 2. I can't remember. 1, 2. I could look it up. Tell me. 1, 2, 4, and 6. So does anyone need any bit of number 1? You had to multiply out first. Right, okay. We're okay with number 1. Any bit of number 2? Okay, so I'm on the wrong page. I'm still on the wrong page. Sorry. So part 1. Am I doing part 1? Yeah, okay. So number 2, part 1. Okay. F of x is equal to 7x squared minus 3 all over x. Okay, so you can't deal with it when the x is underneath the line. Okay, so what we need to do is we need to use our rule of indices to bring it up, right? Okay, so it's x to the power of 1 underneath the line. So when I bring it up, it's 7x squared minus 3 and x to the power minus 1. Okay, is that right? Okay, so it's x to the power plus 1 underneath the line, bring it up, it's x to the power minus 1. Okay, differentiate. Okay, f dash of x, bring the power down in front, 2 by 7 is 14, reduce the power by 1, so it's now x to the power of 1, or just x. Here, bring the power down in front, so it's a minus 1 by a minus 3, so, right, that would be plus 3, wouldn't it? Okay, when you bring the minus 1 down in front, it's minus 1 multiplied by minus 3, which is plus 3. Then reduce the power by 1, so minus 1 minus 1 is minus 2. Okay, now I wouldn't leave it like that. Okay, I would bring the x to the power minus 2 underneath the line again, and it would become x to the power plus 2. You never move the numbers. The numbers, if they're upstairs, stay upstairs, or if they're downstairs, stay downstairs. You can't move numbers, you can only move powers. Okay, is that right? So the 3 stays up. Right, it was always upstairs and it's staying upstairs. Is that alright? Okay. Part 2. Yeah? Sorry, is that okay? Can I go? Right, part 2 is 3, f of x is 3 times the square root of x. Right, we need to write the square root of x as a power. So square root of x is the same as writing x to the power of a half, isn't it? Right, square root of x is x to the power of a half. Okay, so then to differentiate, you bring the power down in front. So it's a half multiplied by 3 is 3 over 2. Right, x to the power, reduce the power by 1. So a half take away 1 is minus a half. Okay, so that's negative, so I'll bring it back downstairs. So the 3 is on top, 2 is on the bottom. I'm bringing this back downstairs and making it x to the power plus a half. Now you can leave it like that, or you can turn it back into a square root. Okay, but to be honest, girls, this here will get you full marks. This line here will get you full marks. You don't actually need to move it around unless, you know, chances are they'll ask you to use it or something afterwards to do something else. Okay, so you don't, here will get you full marks. Okay, are we good? Right, part 3. Am I doing part 3? Yes, no, maybe? Anyone? If no one speaks, I'll take it as a no. Right, I'll take it as a no. Right, part 4? Yes, no, maybe? No. Part 5? Still no one? Part 6? Yeah. Okay. So f of x is equal to 3x to the minus 2 plus 1 all over 2 times the square root of x. I'm going to take a shortcut here and write that as x to the power of a half. Is that alright? Okay. Right, I need to bring that upstairs before. This one's fine, it's upstairs already. sorry. I don't know, my ears too big or too small. As in, do they stick out too much or not enough? Yeah. Right, okay. So I need to bring that upstairs, right? So the 3x to the minus 2 is fine. F of x equals, right? Over here, I need to bring the 1 stays upstairs, the 2 stays downstairs, okay? The numbers never move, but x to the power of half can come upstairs and make x to the power of minus a half. Is that okay? So the numbers never move, just the powers move, right? So then differentiate, bring the power down in front, reduce the power by 1. So f dash of x, bring the power down in front, that's minus 6x to the power minus 3. Okay, and here bring the power down in front, so it's plus, I just write it out, minus a half times 1 over 2 and x to the power of minus 3 over 2. Reduce the power by 1. Would you agree? Is that okay? Okay. Here, just sort that out a bit. Minus 6x to the power minus 3. That's a minus. Plus by minus is a minus. On top, I have 1 by 1. I just have x to the power of minus 3 over 2. And underneath the line, I have 2 2s are 4. Do you know, I'm going to leave it like that because they gave me a negative indice, so I'm going to give them 1 back. Right, is that alright? Everyone see where this bit came from?
Yes, you have to bring the x to the power above the line. So can you leave it below it?
You can't differentiate while it's below the line.
Oh.
So it has to be above the line before you differentiate. Because the rule only applies to x's that are above the line. So you have to bring it up before you differentiate. Okay? Right. That was the last bit of number 2. You tell me 4, was it? Any bit of number 4, please? Part 5, yeah. Okay, so can I take this away? Yeah. So 4 part 5. Okay, so 4 part 5 is f of x is equal to 2 root x plus the cubed root of x. Okay, so we need to write these as powers first. Okay, so that's f of x. The square root of x is x to the power of a half, and the cubed root of x is x to the power of 1/3. Is that okay? Right. Bring the power down in front, reduce the power by 1. So bring it down in front, a half multiplied by 2 is 1. And then reduce the power by 1, a half minus 1 is minus a half. Okay, here it's 1/3 x, and 1/3 take away 1 is minus 2/3. And you know what, just leave it like that. Okay, it's fine. Okay, is that right? Are we good? Right, okay. And 6 was the last one, was it? Anyone need me to do number 6? That was it, so? Right, okay. So we're sticking with differentiation. I'm moving on to the next section, right? And there's 3 rules in the next section, and they're all in the log tables, right? So the first one is the product rule. So we saw stuff, right? Okay, we had a product. Product means 2 things multiplied together, yeah? Okay, right? So, for example, right, in one of the questions there, we had to multiply out before we started, I can't remember. One of the examples, yes, in number 5, right? Okay, we did this as an example yesterday, right? And we weren't able to deal with a product yesterday. Okay, so look, that's a product. Root x multiplied by 1 plus root x, yeah? Yesterday we couldn't deal with a product, so we multiplied into the brackets. Now I'm going to show you a rule where you don't have to multiply into the brackets before you start. Sometimes it is easier to multiply into the brackets, but we need to know the rule. Is that alright? Because sometimes it's actually not possible. Right, okay? So the product rule is, right, and again when I write it down, right, okay, it's going to look crazy, right? So basically, if you have a function, y is equal to u multiplied by v, as in one thing multiplied by another, right? Okay? Sorry, I can make it smaller even. Yeah. Sorry, and you know what? I'm going to treat myself to a new pen because I hate when the pens start to run out. Maybe this one is new, is it? Oh yes. So y is equal to uv, right? It's a product. So when you differentiate it, dy dx is equal to u times dv dx plus v times du dx. That was supposed to be a magic pen that worked, but it's really bad, so yeah, I'm gonna go for it. Okay, right, so it's u times dv dx plus v times du dx. Right, now, that's not going to make sense until I do an example. Right, that's in the log tables. So you don't need to remember it, it's in the log tables. So basically what it is if we have one thing multiplied by another, okay, so if we have example 1, so it's if I say differentiate y equals 3x plus 4 multiplied by x minus 2. Now, if I gave you that yesterday, you would have multiplied it out and differentiated the answer, right? Okay, and to be honest, that might be even slightly easier even now, but we have to learn the method. Okay, so this is a product. It's one thing multiplied by another. Would you agree? It's a product. Product means multiply. So it's this term multiplied by this term, yes? Okay, so you let u equal to the first term. So I let u equal to the first bracket, which is 3x plus 4. I let v equal to the second bracket, which is x minus 2. Agreed? Okay, so u is the first thing you're multiplying, v is the second thing you're multiplying it, because it's u multiplied by v, so it's this bracket multiplied by this bracket. Okay, you differentiate the first bracket and you call it du dx. Because up to now we were differentiating y equals and we called it dy dx. So now it's u equals, so it's du dx. Right? Differentiate 3x plus 4, what did I get? 3. 3. When you differentiate 3x, you get 3. Differentiate 4, you get nothing. Yeah? Okay? Differentiate over here, call it dv dx. Okay? And when I get dv dx, what's the answer? 1, isn't it? Differentiate x, you get 1, because it's 1x. Differentiate minus 2 and you get nothing. Yeah? Okay? So then you fill in your formula, okay? So I'll write out the formula again. So dy dx is equal to u times dv dx plus v times du dx. So okay, so dy dx is equal to u is 3x plus 4, isn't it? 3x plus 4. dv dx is 1, so it's multiplied by 1. Add v is x minus 2 times du dx is 3. So what we're doing is we're using this bit here. So it's this term multiplied by the derivative of the other term plus the second term multiplied by the derivative of the first term. So it's the first term by the derivative of the second term plus the second term by the derivative of the first term. Okay? Right, you don't need to multiply out, okay? Right, unless you have to do something with it. So I'll just multiply out because it's easy multiply out, but you don't actually have to. So you get 3x plus 4 if you multiply into that bracket by 1. Here, I'm multiplying into the bracket by 3, so I get 3x minus 6. So that means dy dx is equal to 6x plus 10. Is that okay? Job done. Are we okay?
Is it not,
Oh, minus 2, it is minus 2, because I read that as a plus. Right, that was a test and you passed, well done. Okay, we good? 6x minus 2, apologies. Right, okay. Right, example 2, when you're ready. Can I do that? Is that okay? So, example 2. Y equals, sorry, just go differentiate. Now, the easiest thing to do here would be what? To multiply out, wouldn't it? But as I say, we're learning the rule. Okay? Right. So you let u equal to the first item in the product. So what will I say u is equal to? What's u equal to? Square root of x plus 4. Now, I know I'm going to be differentiating that, so I might write that as x to the power of a half plus 4. Agreed? Right, you let v equal to the second bracket, which is the square root of x minus 4. And because I'm going to be differentiating, I'm just writing that as x to the power of a half minus 4. Is that okay? Now, differentiate. So du dx is equal to, bring the power down in front, so it's a half x, reduce the power by 1, so that's minus a half. Okay, differentiate 4, you get 0. Differentiate over here and call it dv dx. Again, bring the power down in front, reduce the power by 1. A half minus 1 is minus a half. Differentiate minus 4, you get 0. Okay? Then the formula. So dy dx is equal to u times dv dx plus v times du dx. Okay, so that's dy dx is equal to u is x to the power of a half plus 4 multiplied by dv dx, which is a half x to the power of minus a half. Okay, plus v times x to the power of a half minus 4. Sorry, the minus 4 is not up there, it's down here. Times du dx, which is a half x to the power of minus a half. Right, I'm going to multiply out. Okay, so here I have, if I multiply x to the power of a half by half x to the power minus a half, multiply the numbers, a half by 1 is a half, and then to multiply the indices, you add them, isn't that right? X to the power of a half and x to the power minus a half. What would that give me when I'm multiplying? X to the power of 0, add the indices, right? Multiply here, plus 4 halves, 4 over 2, I'll simplify that, x to the power minus a
Excuse me
half.
please, any sixth year student who has not logged onto the exams portal to confirm their subject entries, please go now to the language lab. Any sixth year students, thank you.
Here I'm multiplying x to the power of a half by a half x to the power minus a half, so it would be plus a half x to the power of, and again, rules of indices, you add a half and minus a half, which gives me 0, multiplied by minus 4 over 2 x to the power minus a half. So I just multiplied out there. Is that okay? Right. Here I have half x to the power of 0. Anything to the power of 0 is what? 1. Here I plus 4 over 2 that, plus or minus 4 over 2 that. Don't they cancel each other out? Agreed? Right, and then I have plus a half times 1. So that's a half plus a half, which is 1. So your overall answer turned out to be very simple. It turned out to be 1. Is that right? Okay? Now I'm going to do the quotient rule as well, right? Okay, because it's very similar to this. Okay, a quotient is something that's divided. It's a fraction. A quotient is it's another word for a fraction. Okay, so there's something above the line and something below the line. Okay, so a quotient so again, the rule isn't going to mean much until we do an example. Was everyone up to speed with me? As in, I didn't cut anyone off by pushing up the board, did I? Anyone need the other board back? No? Right, okay. So the quotient rule is if you have a number on top divided by a number on the bottom, right? Okay, to differentiate that, it's the number on the bottom multiplied by the derivative of what's on top. This time it's a minus the number on the top multiplied by the derivative of what's on the bottom, and the whole lot is divided by the number on the bottom squared. Okay, as I say, the formula is in the log table, so don't worry about remembering it, just we need to learn how to use it. Okay, so I'll go straight to an example. Right, differentiate. Right, you know, for the product rule I could have multiplied out and then differentiated. There's nothing here I can do. I have to use the quotient rule. Okay, so there's nothing for a quotient that you can do. With a product you can actually multiply them and then just differentiate. But with this, there's nothing you can do, so you have to be able to use the quotient rule. Right? So you let u equal to what's above the line. So u is equal to what? 3x. You let v equal to what's below the line. What's below the line? 2x plus 6. You differentiate above the line, and what will I call it? Du dx. Differentiate 3x, and what will I get? Just 3, isn't that right? Differentiate below the line, what will I call it? dv dx. Right? Differentiate below the line, what do I get? 2. Right? Differentiate 2x, you get 2. Differentiate 6, you get nothing. Right? Okay. Then you write out the formula. So the formula is dy dx is equal to v times du dx. Now it's in the opposite order to the other one, and the order is really important here because there's a minus in the middle. Dx all over v to b squared. right? Okay, so filling it in, so it's equal to v, which is 2x plus 6, multiplied by du dx, which is 3. Then there's a minus sign. Then it's u, which is 3x, multiplied by dv dx, which is 2, all over v to be squared, which is 2x plus 6 to be squared. Now, as I say, you don't need to multiply it out unless they explicitly ask you to simplify it, okay? And if they do, you'd never multiply out below the line. You'd never multiply out below the line, right? Okay, so I'll just tidy up on top, dy dx, multiply into that bracket, you'll get 6x plus 18 minus 6x. And as I say, you'd never square out what's below the line. And then above the line, the 6x and the minus 6x cancelled, you're just left with an 18. And below the line, you've got 2x plus 6 all to be squared, right? But as I say, some of them are really complicated to multiply out. You wouldn't bother multiplying them out unless they ask you to, right? Okay, so you wouldn't bother multiplying them out unless they ask you to, because some of them are really complicated to multiply out. Okay, will I do a second one? How am I going? $7.37. Yeah, will I get one done? I will. Example 2. So I won't bother writing the words differentiate. I'll go f of x is equal to 2x squared minus 1 all over 3x minus 1. So you let u equal to what's above the line, which is 2x squared minus 1. You let v equal to what's below the line, which is 3x minus 1. You differentiate and you call this du dx. And if you can't remember what to call it, it's in the formula, it's written there, okay? Equals 4x when you differentiate there, right? And dv dx over here will be 3. If it's okay with you, I'm going to not write out the formula this time because I've been written 14 times already, right? So dy dx is equal to v times, which is 3x minus 1, times du dx, which is 4x, minus u times, which is 2x squared minus 1, times dv dx, which is 3, all over v to be squared, 3x minus 1 to be squared, okay? Right, and as I say, you'd only simplify if they asked you, but I might as well simplify, right? So you get dy dx, multiply here by 4x, so 4x by 3x is 12x squared, 4x by minus 1 is minus 4x. Just be careful here, you're multiplying in by a minus 3. The minus at front, the 3 is at the end. So that would be minus 6x squared plus 3. So minus by minus is plus 3, ones are 3. And underneath the line, never square out the brackets underneath the line. Right, and that would be 6x squared minus 4x plus 3 on top, and 3x minus 1 to be squared on the bottom. Is that alright? So I'm going to give you a few of these to do, page 283. Let's do one, except part 1, because that was the example I did. Let's do 2, except parts 1 and 4, because they were the examples I did. Okay, and then let's do 3, 4, and 5. 3, 4, and 6, sorry, I had 5 done. 3, 4 and 6. Right, okay, so all of question 1 except part 1. Question 2 except part 1 and part 4. And 3, 4 and 5, there's no parts in there, they're just questions. Is that alright? Okay. Do you need the picture in the book? Do you? Yeah, okay.